So this is going to be the review for the transformations quiz for the 8th grade. So remember, transformations really come in sort of four forms. We have rotations, reflections, translations, and dilations. So rotation is turning. So rotation is turning something about the origin, sort of moving it in a circular motion about the graph. Reflection is flipping it across either the x or the y axis. A translation is simply sliding it from one point to another. And then obviously a dilation is either increasing its size or decreasing its size. So blowing it up or shrinking it down. So we're going to go through a few of them here. The first one here, we have the coordinates a, b, and c, and we want to translate it 2 right and 1 down. So a translation deals with adding and subtracting. So translation is all about adding or subtracting a number. So 2 units right, so right and left are x transformations. So right is moving the x coordinate, left is also moving the x coordinate. So 2 units right means you're going to take the x, and right means you're going to add 2. So moving right means you add the number. If I said the 2 units left, I'd subtract 2. 1 unit down, so up and down are the y numbers, up and down are the y transformations. So 1 unit down means take the y value and subtract 1, because down means you're going to subtract 1 from the y. Up would always mean you add 1. So if we rewrite our points here, 1 comma 3, 2 comma 5, and 3 comma negative 2, I'm going to add 2 to every x and subtract 1 from every y. So I'm just going to write it like this so I don't forget. Add 2 to every x, subtract 1 to every y. And here's what we get. So a prime, remember this little apostrophe simply means that we've transformed the point. So a prime means I have 3 comma 2, 1 plus 2, 3 minus 1. B prime, 2 plus 2 is 4, 5 minus 1 is also 4, which I should write a 4 here instead of a 2. There we go. And C prime, 3 plus 2 is 5, negative 2 minus 1 is negative 3. So those would be my 3 new points. Those would be the transform points that I have. So translation is adding, subtracting. If you want to, you can have this little cheat sheet here, this little side grid. So up and down means add to the y is up, and subtract the y is down. Add to the x is right, subtract the x is left. So this little kind of diagram here can help you remember when to add and when to subtract your various numbers. Rotation counterclockwise. So counterclockwise and clockwise have the opposite effects. So counterclockwise does this. So this is your point, x comma y. Counterclockwise says first, make the y opposite. Whoops, opposite. And then swap x and y. So make y opposite and then swap x and y. So here's what I mean by that. Let's take a. Negative 4 comma 2. So the first thing I'm going to do is make y the opposite. So positive 2, the opposite would be negative 2. And then I'm going to swap my x and my y. So it'd be negative 2 comma negative 4. And that would be my new a prime. So the first step is to make the y into the opposite, and the second step is to swap the x and the y values. Same thing for everything. So we'll do b here. 5 comma 7. Make the y the opposite, so negative 7, and then swap. So b prime would be negative 7 comma 5. And then same thing for c. Negative 4, 3. So we have negative 4, opposite of 3 is negative 3. And then we swap the points. So negative 3, negative 4. And then we have c prime from that. Negative 3. There we go. And so these would be my answers right here. So rotations always come in 2 steps. Counterclockwise means make the y the opposite and then swap the x and y. Clockwise would mean make the x opposite and then swap the x and the y. So you're always going to swap for a rotation of 90 degrees. It's just a matter of which one do you make the opposite. So counterclockwise means make the y opposite. Clockwise means make the x opposite. A reflection is a lot simpler. A reflection simply means take the opposite coordinate and make it negative. So reflecting over the x means make y opposite. Or if you don't like the word making opposite, you can say take y and multiply it by -1. That's what reflecting over the x means, is take the y and multiply it by -1. So for here we have 0, 3. Take the y, multiply it by -1, and we get 0, -3. And that's a prime. So -7, 0. Take the y, multiply it by -1, and we end up with still -7, 0, which is b prime. So sometimes your point might not change because multiplying by -1 doesn't change anything, and that's fine. C, we have 2, -2. Whoops, sorry. A little bit ahead of myself there. We have 2, 2 to start with, and then we multiply by -1, and then we get 2, -2, and that's, whoops, that's where we get C prime. So these are my new coordinates. So again, reflecting over the x means make y the opposite value, not x. So a little bit of counterintuitive there. So this is just doing the same thing but with a graph. So rotate 9 degrees clockwise. So let's label this point A, B, and C. Now let's get some coordinates down. So A is 2, 3. That's A. B is 2, -1. And then C is -1, -1. So clockwise means take the x coordinate and make it opposite or times it by -1, and then swap the x and the y. So here I'm going to take the x coordinate and times it by -1, so -2, 3, and then swap so I get 3, -2. So multiply the x by -1, then swap. Same thing here. Multiply the x by -1, so -2, -1, and then swap, so -1, -2. Last one here. Multiply by -1, so -1 times -1 is +1, and then swap like that. So for A, I would graph this point, 3, -2. So 3, -2, that's right there. So that's A prime. B is -1, -2, so right here. That's B prime. And then C is -1, +1, so here, that's C prime. And so my new shape would look like that. What you can see is kind of like it has been turned clockwise this way. So if I imagine this triangle being turned this way, all those points would kind of hit where they ended up at. On this one, it's a reflection. So remember, reflecting over the y-axis means take your x times it by -1. So no swapping here because it's a reflection. Simply take your x and times it by -1. So let's get some points down here for my values. So R, S, U, and T. So R is -4, 3, it looks like. S is 4, 5, it looks like. Let's see here. T is 2, no, sorry, T is 3, -4. Oops, 3, -4. And then U looks to be -5, -5. So this says take the x and times it by -1. So I'm going to times everything in the x column by -1 and get some new points. So -4 times -1 is +4, 3. 4 times 5, or sorry, 4 times -1 is -4, 5. -5 times 1 is 5, -5. And this would be -3, -4. So it looks something like this. 4, 3, which is right there. -4, 5, which is up here. 5, -5, which is down here. And -3, -4, which is right there. And so my shape would look something like this. So again, it's been kind of flipped across the y-axis. You can kind of see these points are now over here, and these points are now over here. The last few here deal with similarities. So similarity means there's proportions involved. So determine if the shapes are similar or not, and then explain why or why not. So if they're similar, that means that every side that corresponds should have the same fraction. What I mean by that is, for instance, this is the smallest side here, right? 8. This is the smallest side here, 6. So this fraction, 8 to 6, should be the same for all the other sides as well. So big side to big side, so 20 to 15, and middle side to middle side, 16 to 12. These fractions should all be the same once I reduce them if they're similar. If they're not the same, then they're not similar. So 8 to 6. Well, if I divide that by 2, I get 4 to 3. 20 to 15, if I divide that by 5, I get 4 to 3. Divide this by 4, I get 4 to 3. These are all the same, so yes, they are similar. Because all the fractions correspond. So if you show this work, that would be your explanation, that all the fractions are equal, so they are similar. That's what similarity means, is that each side should have the exact same fraction when reduced. Big to big, small to small, middle to middle. Now, you can use this property to solve for shapes as well. So for instance, for this one here, shape A and shape B are similar, it says here. Shape A is similar to shape B. Shape A's perimeter is 20. Shape B's perimeter is 15. What is the length of B if the length of A is 4? Well, let's set up the fraction we know first. Perimeter is 20 here. Perimeter is 15 here. So for perimeters, it's 20 to 15, A to B. A perimeter to B perimeter is 20 to 15. Now this fraction should be equal to all the other fractions that shape A and B can make as well. For instance, their length. So the length of shape A is 4. That's A's length. The length of shape B, we don't know. We want to figure that out. So I can solve this using cross multiplication. I can just replace this question mark with an x, and I just need to solve for x. Whoops, my bad. So I can just solve for x and figure out what b is, because again, this is my core fraction. As long as I have one pair of numbers to set up a fraction with, I can just figure out the rest of them just by using this core fraction here. Or, instead of cross multiplying, I could say, what do I do to 20 to get 4? Well, I divide by 5. 20 divided by 5 is 4. Well, that means that the bottom has to follow the same path. 15 divided by 5 will give me x, which means that x is equal to 3. If you didn't know that trick, you could always just cross multiply 20 times x, 4 times 15, and then solve it from there. But oftentimes there will be that trick that you can use to help you out. But again, it's set up your base fraction first using the two that you know, and then set up your second fraction by using the ones that you don't know, and then solve for the missing variable there. So make sure you remember all the different types of transformations and how to work them. Make sure you remember your fraction stuff about the similarity, and you should be good. Hope you enjoy the video. Have a good day.